Hi, this is problem number 6 on moment of inertia. You just go through the problem. Here it is asked to find radius of gyration of the shaded area about an axis normal to the symmetrical axis. We have to find radius of gyration about an axis normal to the symmetrical axis, which means first we have to identify the symmetrical axis, then we can identify the axis which is normal to the symmetrical axis. So in the figure we can see that if I draw central x and y axis, so this is central x axis, and here I will draw central y axis, central y axis. So here you can see that figure is symmetric about x axis, okay, which means that x axis is dividing the figure into two equal parts, okay. Therefore this x axis is the symmetrical axis, okay. In the question it is asked to find radius of gyration about an axis which is normal to the symmetrical axis. Therefore the y-axis is the axis which is normal to the symmetrical axis. Therefore you need to find radius of gyration about y-axis, okay. So instead of directly asking to find radius of gyration about y-axis, he indirectly said that to find the radius of gyration about an axis which is normal to the symmetrical axis, which means you need to find ky. To find ky, we know the formula root of Iyy divided by a, okay, which means you need to find moment of inertia about y-axis here, okay. So to find moment of inertia about y-axis, we have two formulae here, okay. We have two formulae. So in these formulae, what are all the parameters involved? Area values are there, then x values are required, ax and ax square are required, then igy values are also required. So we need to add all these parameters in the table, okay. So in this table I have added all these parameters, okay. Now let me draw the reference axis here, okay. So this is the reference, this is the reference 1 axis, and this is the reference 2 axis, reference 2 axis, okay. Now I will divide this whole figure into a number of components. Let me draw a dotted line so that we can form a triangle here. So I will take this total rectangle as component number 1. Then this smaller rectangle is there. Now I will take it as component number 2. Okay, and I will take this triangle as component number 3. Triangle I will take it as component number 3. Okay. Now let me mark the centroids and let me write the centroid distance as well. So if I take G3 as centroid of the triangle, distance of centroid for triangle is always h by 3 from its base, correct? And for the smaller triangle it is b by 2, okay. And for this larger rectangle also it is b by 2 only, okay. For smaller rectangle it is b by 2, and even for larger rectangle it is b by 2 only, okay. Now let us take components one by one and we'll do the calculations. What is the first component? Total rectangle, component number 1, area is b into d. What is width of the total rectangle? Width is, it is 20 plus 30 plus 20, it is 70 mm, correct? 70 mm is the width, okay. and depth of the rectangle is 20 mm. So 70 into 20 is the area. 70 into 20. So answer is 1400 mm square. The units are mm square, millimeter, millimeter cube, millimeter to the power of 4, and millimeter raised to power 4. Okay. Coming to the x value for rectangle, it is b by 2 always. 70 by 2, 35 mm. Ax, if you multiply, you will get it as 49,000. Ax square will get it as 1.715 into 10 power 6. Please cross check the answers. And IGY formula for rectangle, it is db cube divided by 12. D is 20 into 70 cube divided by 12. Okay. The answer is 571 666.67. Okay. Then we will move on to the next component, rectangle number 2. Okay, component number 2, rectangle 2, rectangle 2. Okay, this are taken as component number 2. Okay, for rectangle 2, the formula is b into d, same formula, b into d. Width of rectangle 2 is how much? It is 30 mm, depth is 10 mm, 30 into 10, 30 into 10, so we will get 300 mm square. X value for rectangle 2 means distance of this G2 from reference 2 to axis. Okay, so this is the x value for rectangle 2. Okay, so it is 20 plus b by 2. Okay, it is 20 plus b by 2. Distance of G2 from reference 2 to axis is the x value for rectangle 2. Therefore, it is 20 from here to here, 20 plus b by 2. 20 plus b by 2. 20 plus b is 30 divided by 2. Okay, the answer is 35 mm. 35 mm. Okay, so and very important thing I forgot to tell. So here rectangle 2, it is an unshaded portion. Unshaded portion, you should take negative sign. Okay, you should take negative sign here while finding the area, and while finding IGY or IGX if required, you have to take negative sign. Okay, because it is unshaded portion. In the problem, it is asked to find a radius of gyration for only shaded area. Okay, so here you need to take negative sign. Then AX value for rectangle is minus 10,500. AX square is minus 367,500. IGY formula, same formula, minus dbq by 12. Okay, y minus, it is unshaded portion, minus depth is 10 and width is 30, cube divided by 12. Okay, it is minus 2,500. Okay, then which is the third component? Triangle. Component number 3. Okay, half into base into height is the formula for area of triangle. What is base width of triangle? See, on one side is 20 and it is symmetric, on the other side obviously it will be 20 only. So overall base width of triangle will be how much? 40. Okay, it is 40 mm. Overall base width of the triangle is 40 mm. Okay, therefore half into 40 into height of triangle is given as 20 into 20. So it will be 400 mm square. Coming to the x value for triangle, means distance of G3 center of triangle from reference to 2 axis. How much it will be? It will be 70 from here to here 70 plus h by 3. Okay, so this is the x value for triangle. Okay, distance of G3 from reference to 2 axis. From here to here it is 70 plus this formula h by 3 will give x value for triangle. 70 plus h by 3, 70 plus height of triangle is 20 by 3. Okay, the answer is 76.67. Coming to the ax, it is 30,668. Ax square 2.351 into 10 power 6. Then coming to the IGY formula, here it is an important step in this particular problem. See, for triangle, see, in one of the previous videos I had derived the equation for moment of inertia of the triangle. Okay, for Ixx and Iyy, the formula which we obtained is Ixx is equal to bh cube divided by 36 and Iyy is equal to hb cube by 36. These are the formula we have derived for moment of inertia of the triangle about x-axis and the y-axis. Okay, in this particular problem, you just look into the alignment of the triangle. So alignment is like this. Alignment is like this. Okay, the alignment of the triangle is changed now. Alignment of the triangle is changed now. So in this case, the formula will be reversed, which means the Ixx will be hb cube by 36 and Iyy will be bh cube divided by 36. Okay, so here the formula to be adapted to calculate moment of inertia about Ig is equal to bh cube by 36, not hb cube by 36. Okay, it is similar to the semicircle. Okay, so when the alignment of the semicircle is changed, no, the formulae are reversed. Similar to that, here for triangle also the formula will be reversed if the alignment of the triangle changes. So here I'll take the formula as bh cube by 36. We are finding Ig no, Ig means I'll take bh cube by 36 formula. Okay, so bh cube divided by 36. So depending upon the alignment of the component, we have to apply the formula. We should not have the fixed formula in our mind. So depending upon the alignment, we have to interchange the formula. Okay, so bh cube by 36. B is how much? Base width 40, height is 20. 40 into 20 cube divided by 36. 40 into 20 cube divided by 36. Okay, for this the answer is 8888.89 is the answer. Okay, see, for IGY for rectangle to know, it is 22,500. Okay, it is not 2,500, it is 22,500. Please correct it. Okay, now we are done with all the calculations. Now we will calculate the total or summation. Okay, summation. Total area sigma A is equal to, it is 1500 mm square. Here sigma AX is equal to 69,000 69,168. Then sigma AX square is equal to, please cross check the answers, it is 3.698 into 10 power 6. 3.698 into 10 power 6. Then sigma IGY is equal to 558.05 into 10 power 3. 558.05 into 10 power 3. Okay. Now we have two formulae to find the IYY. First formula is what? I22 is equal to sigma IGY plus sigma AX square. Let me use that formula first. I22 is equal to sigma IGY plus sigma AX square. Sigma IGY is 558.05 into 10 power 3. Sigma AX square is 3.698 into 10 power 6. Okay. The answer is 4.256 into 10 power 6 millimeter raised to 4. This is moment of inertia about axis 2. Okay, we have one more formula. Second formula, that is IYY plus A into x bar square. IYY plus A into x bar square. First you find the x bar, which is equal to sigma AX divided by sigma A. What is sigma AX? It is 69,168 divided by 1500. Therefore x bar is equal to x bar value that we get is 46.11 millimeter. Okay. Now substitute in this formula. Therefore moment of inertia about axis 2 is equal to, okay, I'll rewrite this formula first, then afterwards we'll submit the values. Okay, I'll rewrite this formula. IYY is equal to I22 minus A into x bar square. I22 is 4.256 into 10 power 6 into 10 power 6 minus total area is 1500 into x bar square, 46.11 square. Therefore moment of inertia about y axis is 1.0668, okay, into 10 power 6 millimeter raised to 4. Okay, now we need radius of gyration. Okay, about the y axis we need ky. Okay, ky is needed. Therefore ky is equal to root of IYY divided by area. Root of IYY is 1.0668 into 10 power 6 divided by total area is 1500. Therefore ky is equal to it is okay, I'll calculate the answer. .0668 into 10 power 6 divided by 1500, and root of answer 26.66 millimeter. Ky is equal to 26.66 millimeter. Okay, so this completes the solution of this particular problem. Okay, and one more input I wanted to give. See, in the same problem, if it is asked to find moment of inertia about x-axis, okay, in the same problem, if it is asked to find moment of inertia about x-axis also, means moment of inertia about the symmetrical axis also. See, as the figure is symmetric about x-axis, Ixx will be equal to what? Sigma Igx. Okay, as the figure is symmetric about x-axis, Ixx is equal to sigma IGX. Means here you need to add one more column, IGX column. Okay, IGX column. Then you have to calculate IGX for individual component. Okay, you will get sigma IGX here. Okay, here the formula will be BDQ by 12. Okay, BDQ by 12. If you calculate, you will get it as 46.67 into 10 power 3. Here the formula is minus dBq by 12. Okay, if you substitute and calculate the answer, you will get the answer as minus 2500. Then here the formula is, here BH by 36 we have, here it will be HB divided by 36. Okay, it will be 35.55 into 10 power 3. Okay, sigma IGY if you calculate, it will be, sigma IGX if you calculate, it will be sigma IGX is equal to 79,720. Okay, therefore IXX is equal to sigma IGX is equal to 79,720 millimeter raised to 4. Okay, so this is the value of IXX. If you want to find radius of gyration about X, it will be root of IXX divided by A. It will be root of 79,720 divided by 1500, root of answer. It will be 7.29 millimeter. Okay, so in the question, if it is asked to find IXX also, so in a very simple steps you can get this value of IXX and KX value, radius of gyration about X axis. Okay, thank you.